Here, I'm going to introduce Jeff Cappellucci is there. He's a graduate student for Geographic Information Science at the University of Denver and an intern at the NREL with Transportation Applications and Data Analysis team. He's worked on several projects, including the Route Energy Prediction Model and the Transportation Secure Data Center. He has particular interest in the spatial energy impacts of transportation and will be presenting on integrating energy into a transportation dashboard environment. Jeff.
Thanks, Frank. How's it going? I'm Jeff. As you mentioned, I'm working with NREL to create a new dashboard, also University of Maryland's CAT Lab. We're working on creating a dashboard that integrates energy-based metrics into a web dashboard environment. So I'll be going over what that looks like specifically and how we want to address that visually. So a few key questions that we want to answer with this research is, first, how do we quantify the energy consumption of transportation? I want to specify that we're focusing on energy, not emissions, although those two are often very interrelated. We're mainly focused on energy for this application. Also, how is this, once we do get the energy appended to the road network in some way, how do we disseminate this to those that care about that in an effective way for them to make good decisions? And lastly, how do we visualize it? What are optimal ways to convey that information to make it more impactful? So a little bit of background. As most of you know, there's already a lot of transportation dashboards out there. VIZ, of course, is a big one. FAST is another example from the Nevada area. A lot of these dashboards, most of them focus on performance metrics, speed, accidents, so on and so forth. Very few incorporate energy into the mix. So that's where we came in, partnering with University of Maryland's CAT Lab and some other partners to create this transportation energy analytics dashboard. The name is pretty self-explanatory, but adding in several energy-based metrics into the RIDIS platform. I'm sure many of you use RIDIS. You're aware of the widgets and analysis tools that they have in there. So this looks very similar to that, where we're adding these new capabilities into that. So Stan presented yesterday, for those that were there to see that. One we're focusing on is energy analysis. NREL's Route Energy Prediction Model is the primary tool we're using to predict and estimate energy along a road segment. And name of the application in order to integrate Rowdy into the dashboard is Rowdy application, transportation energy consumption. So just a brief background on dashboards in general, transportation dashboards. Most of you have probably seen this, where you have various performance and service level metrics that you can visualize on a map. Pretty typical, you see accidents and cameras. And one thing specifically is the probe speed on the road segments. This is a very common color scheme that you see, the red, yellow, green, bad, medium, good, service in some capacity. The question now stands, how do we incorporate energy into this environment? The initial thought was to just, put another layer box here, have energy be the same visualization, the red, yellow, green, high, medium, low energy. But that raises a few questions as far as how useful that is. Just to know how high the energy is on a given segment doesn't really tell you a whole lot. If there's an accident on a major highway and you see the highway light up red with energy, it's not like we're saying, oh no, the energy is going up. We're really trying to look at more long-term trends and efficiency along the road network from an energy perspective. So how do we actually calculate the energy? And this is the most I'll get into as far as methodology goes here. I'll keep it at a very high level. Rowdy is a Python-based model that we use to estimate energy, and we train these models by incorporating various drive cycle data and powertrain modeling data. In this case, we use drive cycles from the Transportation Secure Data Center. We have over 1 million miles of drive cycles. We train these different vehicle types. You know, we have battery vehicles, PHEVs, conventional vehicles, and so forth. We train these models over the TSCC drive cycles and an underlying road network, in this case TomTom, where we have various road attributes such as gradients, number of lanes, and so forth. So we combine all of that into a model that allows us to, in an area where we don't already have good drive cycle data, we can predict or estimate the energy that's going to be consumed on a given trip or segment. If you want to know more about the TSCC, ask me. If you want to know more about FastSim, ask Matt, not me. So Rowdy is intended for, or is designed for green routing, where you have a single vehicle going a specific route, and we're predicting the energy along that route. It happens when we want to go to this situation where we have essentially all routes that we're looking at. That's where we add a couple of variables, such as traffic volume and the average speed along each segment to estimate the total energy that's being consumed within a given time period on that segment. So the big reveal here, as far as the visual goes, what does this come out to be? So this is the screenshot example of what the prototype with the rate C dashboard would look like. Got a brave as Stan yesterday to do the live demo, so we'll just stick with the screenshot here. As you can see, it has some pretty standard visualization widgets. You know, on the left here, you have kind of some infographics with the total energy. This is, for example, an estimated entire year for Columbus, Ohio, as our target area of interest. Graphs such as how the energy, functional road class of each of these segments. Down here, you have some tools where you can specific area and get these, same charts for that area. On the right here, you have a good example of how you would interface with Rowdy, or rate C rather. Take time of day, and a date, and also put in some ratios. So, for example, you say 70% of the cars on this network are conventional vehicles, and so forth. That'll give you this output of the total energy on the road. Last part here is the main part of the visualization, which is to answer my previous question: how do we visualize energy more effectively than the binary color scheme of the red, yellow, and green? So it takes a little bit to digest this here, but once you think about it, I think it really highlights energy specifically in a transportation context. So we're looking at two variables here and their relationship to one another. So we're not necessarily looking at a quantification of total energy, but how the energy relates to the efficiency of the vehicles traveling along those segments. So as you get to the left here, or the pink side, the total energy on the segment may still be high, still could be a popular road, but the per vehicle average energy is lower, so we might see something about those segments where the vehicles are able to traverse them more efficiently. On the other side of it, you have the opposite, where something about these segments of the road, vehicles aren't able to travel as efficiently, maybe uphill, maybe more congested. That would be up to the practitioners and the users of TEED to kind of investigate in more detail once they're able to gain these insights from the visualization. So I think this all begs the question, so what? we're looking at energy on the road network. A lot of people are more focused on emissions. I think there's a lot more, mandates to get your emissions down and so forth. What about energy? Well, Rowdy allows us to train different models for different types of vehicles, like battery vehicles and so forth. So we're able to distinguish between the emissions and energy more specifically, and that'll let us get a little bit more insight on the energy situation specifically. Also with Rowdy, we have some models that we've trained to represent connected and automated vehicles. So we have an example analysis here of, what if in this tool here we inject 20% proportion of connected vehicles instead of traditional human-driven vehicles. How does that impact the energy? So this is what it would look like in a normal scenario. We're seeing, of course, a lot of, up here where it's just higher energy, high volume, as well as, the lower vehicle efficiency. And we have a total down here, estimated total of the gas gallon equivalent of that. When we inject more connected and automated vehicles, unfortunately, but you can see a pretty significant shift on many of these segments towards the purple end here, which is a good thing. So as we shift this direction on the symbology scheme, we're seeing an increase in efficiency on the road segment. See here, there's a pretty minimal, relatively minimal impact on the total energy, but the vehicles are still better able to get across these segments more efficiently. So some caveats here with this, of course, is connecting and automated vehicles. That's a very broad topic. How do we model these vehicles and their ability to connect with one another, and platooning and all of that? There's some assumptions that are being made with these connected and automated vehicle models. The point of this is not about the models themselves, but rather visualizing how these different models can impact the map of transportation energy consumption within the given area. So, in conclusion, a couple of points that I wanted to make here. First is to visualize information and not data. I think Riza touched on this yesterday. It's very important when you're, presenting this information, especially in a dashboard environment intended for users that are more so practitioners and planners. They need to know the information and how to act on it, not the numbers. So a total number on a segment of 10 kilowatt hours doesn't mean as much as showing that the segment, despite the volume, is running efficiently compared to other segments. Second here is to understand the unique attributes of the features that you're visualizing. And what I mean by that is, going back to this visual here, when we're talking about, for example, speed on the road segment, knowing that good or bad is very useful to people that are trying to traverse these segments. A visualization like this makes sense, where red means bad, makes sense to most people, green means good. That's good information. I think in the case of energy, where you're not necessarily concerned about, whether people can get to work on time, you're more so concerned about broader implications of the energy usage and the cost of the emissions and the cost of that. This isn't as useful. More energy, that's great. What can we do about that? Perhaps we should look at it in this context to understand both the volume and efficiency in a little bit more detail. So with that, that's all I have. Any questions?
Okay, question?
Very interesting. Who's your audience for this visualization? Target audience.
As I mentioned, it's tricky. So Columbus is the kind of area of interest for this initial prototype. As we know, Columbus is the center project where they have more concern of energy and emissions and how ultimately the long-term project. I don't know if there's any Cat Lab people in the room. These sorts of metrics are going to be put into the Redis platform, so your Redis users can see these, the normal performance metrics that they're used to, but now they're going to be better able to gain insights into the energy that they might need to know in the near future here.
To follow up on that, so I'm in traffic operations, and maybe it doesn't apply for me, but someone that's in planning and design, kind of following up on your question, what is the expected outcome of this? So let's say that, in Midtown Atlanta, high energy use, what would be what would be the next step for a DOT to say, oh my gosh, with high energy use, what do I need to do about, high energy use but low efficiency? What can we as a DOT, or what should we?
Right. So that's a good question. So, what to do about it, it's a little open-ended, but you can say, for example, this segment, this stretch of road here is showing, pretty inefficient. Mm-hmm. You can use this information to understand rate C. I didn't highlight that as much in this, but it allows you to kind of look at different times throughout the day, throughout the year, historically, to understand, is this visual here just fluke, or is it consistent that this segment of road is inefficient for whatever reason. The variables that are being put into this model are things like gradient, number of lanes, and so forth. You can inspect these different road attributes to see, what the reasoning may be that's impacting the efficiency negatively, to which, that'll give you some ideas of what to do about it. I think the initial goal of this project here is to really get energy on the map. I mentioned there's a big focus on performance, but kind of the point of this session here is climate change and concerns with that. So getting energy on the map is kind of a first step to getting a hold on that.
Other questions? Yes.
What street network are you using for street segments? Is it OpenStreetMap or some other source?
For this case here, it's the TomTom Multinet. I'm glad you asked that question. It does raise the idea of using good data for your visualization. I think a big problem with the Multinet is you may be able to see here there's some long segments and then you have a short segment. It makes it look very choppy and kind of granular. I think in a case like this, a much less granular data set would be more visually appealing.
I think for the symbols that we created for you can see a lot of options. How do you come up with this final symbol? So I think you can also change the and then and
great question. So color theory thing this morning. This is straight from Esri. This is the color ramp that they have in there. Selection of these particular colors is kind of an artistic choice. I kind of like them, but also there's a scientific choice and a visualization choice, and want to be able to show the dichotomy between the two scenarios pretty effectively, but also be able to show the continuum in between. So method over here is very visually distinct. Light blue over there. Could do, when you're trying to visualize two variables, line thickness and things like that. I think that's a little bit more subtle to notice to the naked eye than when you're looking at segments. Road segments might get a little noisy. Questions?
The reason that I brought up the issue of who's the audience, looking at that gradient, the color gradient you're using, it's basically combining two parameters. And unless you were here, I would have had difficulty really interpreting the results. So a visualization that's for non-technical, that was not trained on this one, it will be hard to read this and interpret what it means. So, I mean, for me, ideal, Google is doing great. I can open up their map, look at traffic. I mean, it's traffic. It's a different context, but it's 3 or 4 colors, and I understand them. And 10 seconds, I'm out. So I understand them, and I mean, they spend a lot of time on that. So it goes back to the audience, and what we are trying to say. That was the reason that,
Yeah, I confess that this symbology is not as simple. When you're looking at two variables, it adds complexity, for sure. I think when you take the time to digest a little bit, it makes more sense. There's certainly some changes that could be made, perhaps. I think these default diagonal arrows that Esri provides maybe aren't the best way to explain it in a brief blurb. There could be changes made there. But
overall, I'm basically impressed because this is new. I mean, people aren't thinking about how do we visualize energy. So I think this is a great advancement in that thought process. And this is a whole new way of thinking about how do we communicate these two different parameters, and certainly not using the red, green, yellow makes sense here. So it already moves us out of that. I'm also aware that in terms of the audience, this is a great visualization tool for the practitioner. This is not what we give to the decision maker. This is how we find that answer. I suspect that what you can do is kind of model different scenarios with this.
Exactly.
But bottom line, it's going to turn into a bar graph. That if we do this, this is how much energy we use. If we do this, this is how much energy we use. Now, this is the background that validates why that data is important. Yes, we've actually modeled this. This is coming from a real place. Here's all of the background and interesting stuff. But in terms of communicating to the decision maker, it's going to be much simpler. Yes, this is what happens when we use this data. So, yeah, thank you. Thank you very well done. Question?
I'm also super fascinated with this idea of if you also thought about using a different way to was there any thought about making there's a height?
I think so. The challenge I think there is with 3 dimensions and polyline data is they kind of look at it at a different angle. They can block some road segments, so requires for purposes of this project, just wanted to keep it in line with what RITIS has currently, which changed on me. I don't think they have any 3D stuff, so just kind of keep it
definitely advantages and disadvantages, but one of the nice things, so some things that you can't show, that's great work.
Thank you. So my role as a GIS person, I'm not the web developer on the UMD Cat Lab. That's going to be more up to them. My understanding is later, towards the end of this fiscal year, so September, is when they're going to have more. That would be a better question for Mark Franz.
As a follow-up, it looks like you will have a pretty high resolution. They find it, I guess, like possible to use like the.
Yeah, so for this application, I'm mainly just using the TomTom Multinet as a test case or prototype. That I highly doubt that Redis is going to use the TomTom Multinet. They're going to use their own road segment data. I didn't have access to it, or externally to use it in the initial analysis, so I picked it instead. But I imagine they'll have much less granular data. With Rowdy, there are some issues with very, very long segments and very, very short segments on the energy prediction. Worked on as well. Side note to that, if you Google Rowdy, you're not going to find anything, I hope. We're planning on publishing a paper at the SAE.
Well, let's give a round of applause for our two speakers. I think they've been able to stretch our imagination in what we're kind of dealing with, and as climate change becomes a bigger and bigger challenge that our entire world is going to have to address, all the way down to the personal choices that people make. It'll be fascinating to see, how all of this will help affect how we get there. So thank you very much.